about three different things and kind of how we work with graphs. So the first one is analyzing a graph to say what is happening in this graph and describing that using words, right? So I've got this graph here where I talk about the title here is air in the balloon, right? So any guesses on what my variables are here? What are my variables on this graph? Volume and time, right? The axes, what's labeled, those are my variables, right? So volume and time. And so now I need to kind of think about what's happening in this graph. All right, so I'm talking about air in a balloon. What happens right here in this first kind of red part? It's rising. So what's happening to the balloon? Or what had maybe started happening? What is someone doing to that balloon? Starting blowing it up, right? Starting inflating it, right? So I can say I start blowing up a balloon. All right, so I start blowing up a balloon. And then as I look at my graph, what does that mean? To take a breath, right? Volume's not going up, but time's going by, right? So I can say, then take a breath. And then what happens next? Yeah, right? Start blowing again. And then what happens? Yeah. So take another breath. So then we've established, right? Starting, so when I go up like that, right? So start blowing again until something happens, right? So what does this drop from the top to the bottom mean? Pop. Balloon popped, right? I lost all my volume at one time, right? So you can say start blowing again until balloon pops. Okay, so that would be how I would describe a graph using words, right? So now when you start looking at these things on classwork assignments or maybe you're comparing answers with somebody, your story might be worded a little differently, right? But as long as you guys have the same gist of things, you're good, right? So that's our first one, right? They'll give us a graph and we'll start kind of analyzing it and writing it down in words. Okay, so any questions on that part? So the other thing we're going to look at is how do I sketch a graph, right? So now they're going to give me the word, right? Give me the situation, and I need to draw a graph for them. So first thing I would do is read through the situation, right? And I'm going to underline things that seem important. Right? So the model rocket rises quickly, right? Then slows to a stop, right? As its fuel burns out. It begins to fall quickly, right, until the parachute opens, after which it falls slowly back to Earth. Right, so those are the 4 points of the graph that are important, right? That's where they start talking about its kind of height over time. Right, so I put time on the axis there, the x-axis, because that's what's changing here, right? That's kind of what I'm controlling the time since I launch it. The height is what's dependent on the time. So now I need to think about what is this graph going to look like? So if I think about back to chapter 5, and we've talked about slope a lot, right? If something's rising quickly, what does that mean that slope is going to have to be? So it's going up, right? I have a positive slope. But I can have lots of different positive slopes. So what is this slope going to have to be? Or this line should be what? Steep, right? If I'm rising quickly, it means I have a high slope. So I want to start, right, by kind of rising quickly, right? So I'm going to call that kind of section 1. Start rising quickly. Now section 2 here, right, which I'm going to draw in red, says then I slow to a stop. So what's happening to my line now?
It's like you're resting because of the pause.
So let's think about that. If I'm rising quickly and slowing to a stop. As it's slowing to a stop, is my height still getting higher?
Yeah, but it's just slow.
Yeah, right? I'm still getting higher. Think about how a rocket's going to go. But I'm just not doing it as fast, right? So maybe I have kind of this curved line, right? Things are kind of slowing down as it goes, but it's still getting higher. Okay? And so now if I look at section 3, right, it begins to fall quickly. Right, so quickly said I should need a kind of steep slope. But what kind of slope is it going to be if I'm falling? Negative slope, right? So now I need to start going down kind of quickly. Right? So I've done all that. Right? And then I have section 4 here, right? Fall slowly back to earth. So now I'm thinking about still falling slowly, right? We talked about falling negative slope. We've looked at slowly before. Where is this line going to stop? Right? As I kind of draw my slowly line. Where? Did you say something, Deegan? At where? Okay, so Deegan says something like this, right? I kind of have this slow, kind of close to that last arrow. Why do I want to stop before I go below that arrow? What does that bottom axis represent?
0.
0 and what? Height or time? So what is this bottom axis? What's the value of the height? 0, right? Ground, on the ground, it's that. So I can't go below that line because my rocket's not going to go into the ground, right? It's going to land on the ground with the parachute. So that's why that stops there, and I get section 4. Okay? So again, with like number 1, right? Your guys' graphs are going to look a little different than mine, right? Somebody might, when you're doing this on your homework, they might only use up half the graph, right? As long as you have those 4 sections or whatever it talks about, you're good, right? So they might look a little different, but make sure you're looking at having the same kind of general idea. Okay? So any questions on that? One more example. Looking at, now what if they give me a table and I want to match this to a graph? So this is telling me here that I have this band that allowed people to download their new video from their website. And so the table shows the number of downloads that happened after day 1, day 2, day 3, and day 4. And I need to figure out what graph is going to best match that data. So here's one thing I'm going to tell you to look at. Is I can think about slope in a similar way here by looking at what's the change in the total downloads. So I just want to estimate this, right? So 300 to, like, let's say 346 to 1,000. About how much more is that? Yeah, right? About 700. Doesn't need to be perfect. I just want to know about. So what about 1,000 to 3,400? 2,400. And then 3,400 to 10,400. About 7,000. Right, so now that I've looked at that, right? What is my slope going to be? Positive or negative? Positive. So what is there a graph that I can get rid of right now?
Yeah, negative.
D, right? I can get rid of that negative slope. So now I've got to look and say, okay, I've got a graph with a linear equation or a linear slope, right? Straight line. Or I've got two that kind of curve. So I would first ask to say, do I have a linear slope?
No.
Why not?
Because it don't go up by the same amount each time.
It's not going up by the same amount, right? It's 700, then 2,400, then 7,000. So I can't have a linear slope, so I can't have that one. So now I've got to look and say, okay, I've got these two lines. They're kind of curved, right? But which one is it?
B.
So why B and not C?
Because the last dot on B, like the highest one is the one, like the one that increased most. Because that one's kind of angling off the
Okay, so what John's saying is that I'm growing quite a bit from between the second to last and the last one, right? So that one went up, but if I look here, right, this is kind of going almost headed back down, right? So I have to have B because that's the one that's showing it kind of increasing more and more as time goes on.